Thank you so much for coming. This is a big room with lots of people. It's a bit scary. All right, this talk is about secure coding. And it's a topic that I hold really close because it's so important. And I've been to a lot of different conferences where a lot of the talks, they kind of assume that you already know a lot about security. And so the idea of this talk was to try to kind of rewind a bit and then start with some of the basic stuff that we need to do. And this should be useful both for new and seasoned developers, I hope. So who am I? I'm Erlend. I have worked as a developer for well over 18 years. Some of the experience I'll talk about today is from a project I worked on for several years, where I was both a developer and a DevOps person and all kinds of stuff. I also do a little bit of security tooling, open source security tooling. I built a tool called Retire.js, so that some of you might have heard of. And I'm also involved in OWASP in Norway. One of the big problems we have when it comes to security is very well phrased by Bruce Schneier and others. It's that complexity is the enemy of security. And I really find this to be true because if we're going to secure something, we have to understand how it works, and then it has to be readable, it has to be testable, it has to be all kinds of things. And usually things don't start out as complex. It's something that happens over time. We keep adding new stuff, we keep expanding, adding new functionality, and we are quite bad at removing stuff. So we keep adding new stuff, adding new stuff, adding new stuff, and then things tend to rot and become a huge mess at some point if we're not super strict about it. And vulnerabilities are bugs. Some people talk about vulnerabilities as though they were something really special. Like, oh, vulnerabilities, they need to be treated in a very different way. But the complexity that we have, they lead to bugs, and some of these vulnerabilities, or some of these bugs will be vulnerabilities. And it's also been estimated that 50% of these vulnerabilities are business logic bugs. So, and the reason why that's important is because if we're using like a code scanner can only find generic stuff. It doesn't know about the domain that we're working in. It doesn't know about our business. So it can't find certain types of bugs. And so it's up to us to fix that. But about these bugs, I have a personal preference of bugs. So the bugs that I like best are compile time errors, because I'm forced to fix those immediately. So if I can get things to become compile time errors, that's perfect. Then I'm happy. The next one is stuff that's caught by automated tests, of course, because then I can find it as quickly as possible, and I can fix it, and then I can go back to the normal churn. And after that, we have stuff that's caught by code inspection. And code inspection can be both manual review, or let's say we have a test tool that runs and scans our code and reports stuff. Then we have stuff caught by a manual test. Well, I was just up listening to Michael Bolton, and he told me that there's nothing that's called manual test. It should be called experience testing or something like that. But let's just call it manual testing for now. And then it gets worse, runtime bugs. These are the bugs that actually make it into production, and now it gets worse. And then vulnerabilities. If we have vulnerabilities in production, that's not a nice feeling. And of course, it gets worse when it's an exploited vulnerability. And even worse if it's one of those things that only happen at certain conditions, and it's hard to find them, and you're stressed out, and you're working on it for days, and you can't really figure out what's going on. So we have all these kinds of bugs. And I was thinking about this, and how can we make things into compile time errors, or basically move bugs up the chain. But now I'm going to rewind a little bit. I'm going to rewind back to 2006, and I don't expect you to read this. This is a picture of a blog post I wrote in 2006, where I was thinking about some of the problems that we have when it comes to security, namely cross-site scripting and SQL injection, because those keep popping up all over the place all the time. And I wrote this blog post, and I wrote a series of blog posts, and then I got in contact with a couple of Swedish guys. Danberg Jonsson and Jon Wilander, and they were thinking about something they called domain-driven design, and it turned out that we had really similar ideas about stuff. So the idea of domain-driven design or domain-driven security is that we take stuff from domain-driven design and we use that for security purposes. So they even, Dan and a couple of other people from OmegaPoint, they also even wrote a book about it called Secure by Design, which I highly recommend if you want to dive deeper into this. It's a really, really good book, and it explains a lot of the ideas that I've been using and the stuff that we came up with on this. But I'm not going to take credit for the ideas. I think that's mainly Don and Daniel's ideas. So one of the things that they talk about is this thing where different departments within the same company, they might have used the same words, but it's not necessarily exactly the same. So in a sales department, maybe if we're selling something, a quantity is, well, we want to sell at least one thing, but we don't want too big orders. So let's say it's between 0 and 200. But then in the returns department, we might actually want negative numbers. But you can see that these concepts don't necessarily go hand in hand. We don't want someone to order minus 200 things in our web shop. That would be terrible. But in the returns department, that's fine. But that means we have these concepts that we have to handle, and we have to handle them differently, even within the same company. So, and thinking about this and thinking about what happens a lot, we quickly see that the same piece of data also flows and occurs in different versions across an application. So this is like a standard application where we have a database, we have some kind of query language, maybe SQL, maybe something else. We have some server-side code running. This could be Node.js, could be Java, could be .NET, anything. And then we have some JSON that's going back and forth over the wire, up to some kind of template engine that's running in JavaScript, and then that becomes HTML. And the reason I'm showing this is the same piece of data, the same entity, has many different representations in this drawing. So it can be a row in a database, it can be a part of a query, it can be a server-side object, it can be represented as JSON, and it can have multiple different representations in HTML. For instance, a user object can be a profile editing page, it can be an avatar up in the corner, it can be just a display name, it can be all kinds of things, but it's essentially the same piece of data. And the places where we have all the security vulnerabilities, or many of the security vulnerabilities, are usually when we go from one representation to another. So when we go from JSON to server-side objects, there's a lot of stuff that can happen there, for instance, deserialization attacks and stuff like that. When we go from server-side objects into SQL, then we can get SQL injection. So these transformations are super important. And this is also where we're failing. So the first thing that comes to mind, of course, is input validation. So we need to make sure that the data that we're getting is on a specific format. And I think the goal of input validation should be that the data is valid in the domain of the system. So not necessarily that this is a security thing, it's more of data should be valid. We should have valid data. We should not be allowed to order minus 200 books, because that doesn't make sense in the web shop. But that's more of a domain thing, not just a security problem. But luckily, input validation has a side effect, and that's that it stops a lot of attacks. But we'll see that that's not necessarily true. So there's different ways of validating input. So there's syntax, that's basically the format of the thing that we're getting. Does this look okay? And then if we have multiple values, we can start to think about those values in relation to each other. Do they make sense in this context that we're in? And then we can even do something called domain validation, where we're checking if this makes sense in our actual system. So this could mean we have to look something up in a database to see if this is a valid ID, for instance. And it's easy when you get started, like validating a date. When someone was born, we could start with something simple and say, well, it needs to be some 4 numbers, and then 2 numbers, and then 2 numbers. But now we're allowing like 999 as a year, and that doesn't make sense. But the syntax is probably correct. But then we can apply the semantics. So we're saying, well, it needs to be, someone can't be born in the future, at least not in this system, and maybe we're not going to care about people that were born 200 years ago, because they could never be a user of this system. A product ID, we could check, is this numeric? And then we could have a domain validation that checks, well, is this actually a product that exists? And we do that before we start using this ID all over the place. So that's a couple of easy ones. And then it gets a bit more complex. So you want to allow people to write comments on something or write some free text. And then, well, we start with something easy like letters and numbers and dots and stuff. But then, let's say this was Stack Overflow that you were implementing. Then you're actually starting to allow people to write stuff that could be attacks. So here it starts to get a bit more difficult. Another problem we have is this thing that the same piece of data can be represented in many different forms, even within the same thing. So for instance, in XML, an empty tag can be an open and a close tag, or just an empty tag. In JavaScript, we have these funny things where we have strings that have different lengths, even though they look like both of them have a length of 1. One of them has a length of 1, and the other one has a length of 11. Because it's like the emoticon with the mom and dad and kids and stuff. And so JavaScript thinks, hey, length 11, perfect, fine. So we need to make sure that we're treating things in the same way. And same thing holds for emails and host names and stuff like that. Some of you probably saw that there was recently a Punycode vulnerability in OpenSSL. So this happens all over the place still, that we have these problems. So I'm going to leave you with the first principle of the day, and that's don't try to clean up invalid input unless you absolutely have to. Just reject it. Say 400 bad request, I don't want this. Take it back. Try again. It's not always possible, but if you can, reject it. Don't try to clean up stuff that comes in from your user where you're supposed to get a number, and it's a number with some stuff added. Well, then it's not a number, so reject it and say, I don't want this. And then we have the different steps that we need to go through to do input validation. And this is a bit difficult, the two first ones. Should we normalize first or check the length first? Or maybe we need to do both. Because if we normalize first, we know the actual length of the thing, because then we might end up rearranging some letters and adding a new bytes or stuff like that. But then if we go straight into normalization, we might run into security bugs in the normalizer. So. But at least it's important to check the length as early as possible. And then we can check the format and stuff like that. Because a lot of bugs, they have to do with large inputs creating some kind of havoc. So we check the length first, and then we go to the next steps. So we check the format, we check the semantics, and then we use the actual normalized value. We don't use the original value, because now things might have changed. We might have validated something, and we're using something else, which can quickly become a problem. And then later, we check the domain, if we can, if it's needed. But I talked about domain-driven security, and this was just really basic input validation. What we do with domain-driven security is we start to think a bit more about the way we write our code. So this is a bug that was in Mac OS, where they were supposed to show the password hint, but accidentally show the password instead of the password hint. And you can think about this. How did this happen? Well, you have two strings, and oh, I took the wrong one and put it in the box. It's easy. They were both strings, but one of them was the hint, one of them was the password. Okay. And then there's Einar, who's speaking at this conference. He wrote this lovely little thing on Twitter. Did I mention I hate string? And then he says, people who have the decency to refrain from using object will gladly use string with assumptions. And I think that's what we're all doing, or a lot of us are doing. We're using string with assumptions. We're using strings a lot. And then I found this other blog post that's called Something Isn't Something Else. And we scroll down a bit. There's this diagram here, which also is great. So we have a concept in mind, and then we have the actual implementation of the things, and they don't align. So we think something is this way, or this is the way it's supposed to be, but then it's a bit skewed. It's not exactly what we thought it would be. So one of the problems is we're using strings. We're using strings a lot. We do things like this. We're going to register an account, and we go string email address, string password, string phone number. They're all strings. But a string, it can be empty. It can be 2 gigabytes. Are these 3 concepts all the same? Is an email address and a password and a phone number the same? Well, if we look at the total amount of possible strings, I don't think phone numbers and email addresses necessarily overlap. They could in like a zip setting, but anyway. So why are we modeling them as the same thing? Why not do something like this? Email address, password, and phone number. Now we can't do the Apple bug where we switch them around because they're now two different objects. We could even do better. We could put this in an entity that kind of encapsulates them. So what is this thing? Why? What are we doing with these email address and password and username? Well, they are what we call a domain primitive. So the thing that a domain primitive does is it takes a value, a string value or number or whatever, and then it wraps it and enforces the invariance, the rules, the input validation. It does that. So whenever we have an instance of a domain primitive, we know that it is valid, at least syntactically and semantically. So what we're doing is we're taking an implicit concept, like the concept of an email address or the concept of a password, and we're making it explicit in the code. So now we might actually get a compile time error if we try to flip two arguments. So here's an example. This is what we started out with in the project I worked on. We have a phone number class, and this was Java at that time. So we have a class that's called phone number. And it takes a string phone number, and it assigns it to a parameter. And it does this. This is quite basic, right? But there's obviously needs to be more. First, there needs to be a field to assign it to. And in this case, we made it a public final field, because we wanted these objects to be immutable. And if they're immutable, there's no point in having a getter, because it does the same thing. Like, you could just access the value. You don't have to have a getter. But at least that's our thought about this. And then we added the validation. And in this case, we added it as a function. So we said, is valid phone number? If not, we're throwing a validation exception. And we throw a specific exception so we can catch it and handle it specifically. And what's this function? Well, we made it a static function. And the reason why we made it a static function was so we could call it without invoking the constructor, because we didn't want to throw exceptions all over the place if we didn't have to. So by making it a static function, we could also call it from other places if we just needed to validate a certain string. And that made things a lot easier. Of course, in this case, you also have to implement equals and hash code so you can compare objects and stuff like that. But I'm going to leave that out for the next examples. But this was our implementation in Java. And we also added other things to these objects because they now had a logical placement. For instance, for a phone number, well, get country code, well, that sounds like something that belongs to a phone number, so let's add it to this class. And so we suddenly had all these things that used to be like utility methods sprinkled all over. They now had a placement in the code. But then, after a while, we switched to Kotlin. And we wanted to do this a bit differently. So in this case, once again, we had a class that was called phone number, but this time we had a private constructor. And then in the constructor, we did just a check of that this value that comes in, it has to satisfy some checks. And what are the checks? Well, they are the actual validation rules. But those were defined in a companion object, like the static part of a class in Kotlin, because then we could use them differently. And then we started to borrow stuff from functional programming, like in either. So we created a create method where you could give it a candidate string, and it would either return a phone number or it would return a validation error. And the beauty of this is we could now, instead of using exception handling with try and catch and stuff like that, we could grab these errors and we can combine them into an error message and stuff like that without having to do exception handling. And we could do the same thing. We could just do something like this. If we could add this is valid thing again, and then just check if it returns the right thing or if it returns the left thing. So we had essentially the same thing. And this made the code a lot easier to read because you were forced to handle the validation errors and ensure that those got back in the right way. But there's some validation that we can't put in the primitives. So for instance, let's say we have an email address, and it must be unique in the system. That's not something the primitive itself can know. It can't know if it's unique or not. It can only know the syntax. A phone number, it has to be a mobile phone number. Well, what is a mobile phone number? How do we know if a phone number is a mobile phone number? Well, there's a big library from Google with all the kinds of different rules for different countries, and it's very different from country to country. So that's also something that you wouldn't add to the primitive itself. It needs to be checked by some utility method or something in this case. And then maybe you have rules like this. So the password should not contain the user's email or phone number, and should not contain any of the user's names, and it should not be a commonly used password from data breaches. Again, this is not something the primitive should know anything about, because the primitive should only wrap a value and look at that. So we will need some validation services as well. But now at least we have places to put things. And some of these we can put in entities. So for instance, the user registration entity that I mentioned, it can handle these checks for the password. So it can check, well, the password should not be able to maintain, or to contain the email. It should not be allowed to contain the phone number. And it should not be allowed to contain any of the names. So we have a placement for that as well. So in this case, we take the semantic stuff and we move it up to the entity that encompasses these things. And that, again, we have a placement for it. We know where it is. And if we have a user registration instance, we know that that has valid primitives inside it as well. So we know that all of this is now valid stuff, which is super nice to work with, because then you don't have to do validation all over the place. You don't have to check it stuff. And of course, using Kotlin also made it even nicer, because you don't have to handle nulls all over the place like you do in Java. And then it comes to storing the password. And as you can see up here, there's the concept of a validated password. But we only had a password earlier. So how do we get a validated password? Well, we could have a password validator that checks against these lists. So the password validator could be a service that has we have downloaded some of these lists of the most commonly used passwords, and we just give it to the validator and say, you're responsible for transforming a password to a validated password, or returning an error. Again, we have a placement for stuff, and then once we have a validated password, we know that this is already something that we're allowed to use with other systems. But we're not accidentally going to store a password where we're supposed to have a validated password. And this might sound cumbersome. Oh, I have to write all these classes for all the strings and stuff. But in the end, it made things so much easier for us, because we always knew where to put things. We caught bugs that we would normally make, where we would accidentally switch two strings around and stuff like that. So it made things a lot easier. So as I said, the main primitives, they handle the syntax and semantics, and then we can have services that transform them. Let's look at an API. So we talked about bugs that could occur during these transformations. So one problem that especially we've seen in Ruby on Rails is people were exposing domain objects directly out to the clients. So let's say we have these two rows in a database. They go into a server-side object, and then they're exposed to the client. A bit later, we're adding this new field to the database, and this is a secret field. We don't want anyone to see this. This could be like a credit rating or something like that. And we don't want our normal users to see this field. But because we expose the model directly, these things just flow out into the clients. It's available in the API. It might not be shown in the website, but it's available in the API. And it gets worse. What happens if we have a form that only has two fields? And when a normal user is using this, we read out the data from the database, we overwrite the two pieces of data that the user submitted, and then we store it back in the database, and everything works perfectly. But what happens if we have a malicious user that actually adds the third field and then submits the data? In this case, because we're just reading out the stuff from the database, we take the stuff coming in on the wire, we just overwrite all the fields, we're actually going to overwrite the last field as well and store that back in the database. Has this ever happened? Yes, definitely. This is a bug class called mass assignment. And this is a guy called Egor Homakov. And Egor Homakov, he created a GitHub issue that was 1,001 years into the future. Because what he did was he overwrote the created at field when he was editing a bug. So he could set that to anything he wanted to. And you should really look this up on GitHub because it's super funny, this thread. They close the bug and says, yeah, this is funny, haha. And then he opens the bug again because, of course, he can open the bug. He can overwrite the open-close flag with the same technique. And it keeps going like this. And it ended up with him adding his own SSH key to the Ruby on Rails repo on GitHub, and then he was kicked out of GitHub. But he did all of this to prove that this was a problem. So what can we do about this? Well, we can use a contract layer. And this is super easy. Well, we have our data on the database, and we have this secret thing that we don't want to expose. We read it into a server-side object, and then we copy it into the actual thing that we're going to use on the wire. So a DTO object or contract object, or call it whatever you want. And then we expose that. So this new secret field, whatever we add, as long as we don't add it to the contract object, it's not going to be exposed. And the same thing happens if we go in the other direction. So the attacker adds this extra field. This is Egor Homokov changing the created at flag and sending it back. But this field doesn't even exist in our contract object. So there's nowhere to put it. So we're just going to grab the two values that we have, and that's what's going to go back to the database. And so we kind of circumvented the whole problem. Now we have an API that's stable, and we can do anything on the right side of the server, because now that's our stuff. It doesn't touch what's happening over the wire at all. So this frees us up to change that as much as we want. So this is how an order could look over the wire. So again, this is of course strings and numbers, because JSON is strings and numbers and arrays and objects. There's no special thing with that. So when we are going to read that into a DTO, we are using strings. So here we have an order DTO that has an ID, that's a string, and then it has a list of items. And each of those items, they contain the quantity and the product ID, and those are another DTO. And what we can do now is we can let this DTO know how to transform itself from a DTO and into a proper domain object and back again. So we can add a function called toDomain, which will try to invoke the constructor. In this case, it would necessarily cause an exception if it failed, because there's no either in this case. And then it can also do the opposite. So we can have a static method where we take a domain object, and this object knows how to transform the domain object into a DTO. So again, we have a logical place for these functions. But they have nothing to do with our business object, which is the order. The order should not have to care about how it is sent over the wire. That's for the DTO to know. And that gives us also a really nice way of writing actions in controllers, because now they have some really specific purposes. The first thing they do is we take all the input from the HTTP request. This could be like the body, it could be headers, it could be all kinds of things. And it creates the domain objects and validates them by creating the domain objects. Then it calls the correct processing method, and then it maps the result back to an HTTP response. So we get really simple controller methods now. They do the same thing, all of them. They grab some data, they send it off to the right place, and then they convert the result to something we can send to the client. And we had this as a rule, like a controller should never do anything specific. It should just do this simple wrapping. So now they have a responsibility, and the responsibility of actually handling the data, that's someplace else. But if there's a validation error, we catch that as early as possible, and we give back an error, which is super nice. So further down in the stack, we don't have to care about the HTTP request anymore. We now have a proper domain object where we took all the stuff in. But again, there was this blog post that I mentioned from 2006. And the title of it was, Why Input Validation is Not the Solution for Avoiding SQL Injection and XSS. And I found a really good example of this. And it's this tweet. So this is probably a Dutch guy, and he has a quote in his name. And he's obviously had this problem quite a few times where he registers on some service, and there's an exception. And in this case, you could see there was actually an error message that contained SQL stuff, like clear text password and all kinds of stuff. And this happens simply because he has a quote in his name. So let's think about input validation. Are you allowed to have a quote in your name? Well, it is his name, so he should be allowed to have a quote in his name. But that means we can't stop SQL injection by blocking the quote. Then he would have to go under a name that wasn't really his name anymore. And the same thing with the Stack Overflow comment where you had script in it. It is a valid comment. So SQL injection and cross-site scripting, they are not input problems, they are output problems. We have a piece of data and we're transforming it into something else. We're transforming it into HTML, or we're transforming it into a SQL statement. And that's where the problem occurs. It's not an input problem. But by applying input validation, we remove a lot of the problems that we might have, but in this case, it's not enough. I'm not saying input validation is useless. It's definitely something we should do. We just have to do more. So the problem with all kinds of injection attacks is that data does not stay data. Right? It's supposed to be data, and it suddenly becomes a part of the HTML, or it suddenly becomes a part of the query and modifies the query, or it suddenly changes the whole way the application works because it's instantiating different objects than we expected. So we have to ensure that data stays data. And there are ways to do this. Like, we all know that we should use parameterized queries to stop SQL injection. And luckily nowadays, we have a lot of these good JavaScript frameworks that in most cases handle cross-site scripting for us. We can still shoot ourselves in the foot if we want to, but in most of the cases, it handles it correctly. And for other types of injection attacks, we have to look at escaping, encoding, and maybe sometimes block listing and stuff like that as well. But then I have a confession. I failed to communicate at some point. So I was doing a security test for a system. And what I found was something like this. So we're obviously taking some input in the form of a string, that's an ID, and we're concatenating this to build a query. So classic SQL injection. So I wrote a report and I told them, hey, you have to start using parameterized queries to fix this. Of course, this was what I expected them to do. So, like, okay, we had a question mark here. We do like statement set string, very classic Java, this thing. But that's how they were writing their code. So that's why it was this way. And this is what I expected. But what I actually got back was this. So all they did was switch from execute query to prepare statement, and then they kept doing the concatenation. And this is my fault. I didn't communicate this clearly enough to them and told them that, well, you have to move it out of and not do string concatenation. I just told them you have to use parameterized queries, which was not enough. So this was my fault. But then can we do something with the APIs? Can we make it impossible to make these mistakes? There is actually a really good example of this that someone made within the last years. And that's something called trusted types. Now, trusted types is in the browser. And with trusted types, we're trying to avoid cross-site scripting by changing the APIs of the browser. So classic DOM-based cross-site scripting means we're taking some tainted data, meaning some data that the user controls, and we're somehow adding it directly into the HTML. Either we're using something like an assignment to inner HTML, or if we have built a component that somehow deep in some hierarchy is using this dangerously set inner HTML thing in React, but it's not visible from the outside. So if you're using my component now, you might not know that it's deep inside, it's using dangerously set inner HTML. It's an awesome name to call it dangerously set inner HTML, because if we're doing that, we know we're doing something that could cause problems, but sometimes we tend to hide this within a component, within a component, within a component. So how can we fix this? Well, trusted types is one way that a guy, I think it's Christoph Kotowicz from Google, who was the author of this. And what you can do is you can tell the browser that, well, if if you see this header here, then you should enforce trusted types. So what does that mean? That means we can no longer assign something directly to inner HTML. So this is the error message that you would get from Chrome. It says, well, you're trying to assign a string to inner HTML, but I only support trusted HTML. You see how we changed the API? You can no longer assign a string. You have to assign something of the type trusted HTML. So how do we get something that's a trusted HTML? Well, we can create a policy. So we create a policy, we give it a name, and then we have this method inside. It's called create_HTML, and that needs to return something that's been cleaned up and is safe. And then we can use the example policy to create HTML. And the best way to do this is with a library that's called DOM_Purify. DOM_Purify is built by some excellent security people that knows every bit and piece there is about cross-site scripting. And this is a library that keeps getting updated. And they added a return option that says return trusted type true, and then you can do the assignment. You just have to add this sanitize thing around it. And you can change the policies and make it work the way you want. But again, now you have to remember to use this DOM_Purify sanitize thing whenever you want to do it. But there's even a better way, because there's something called the default policy. And the default policy is used whenever you just try to assign a string to inner HTML. Then it automatically goes to the default policy, calls the create_HTML method, and then runs the assignment. So now it's suddenly safe to use again. And we don't have to do anything except add this. And it even works deep within libraries in places where we didn't think about it or we didn't want to change because it was like a third-party library that did something wrong. So it even works in there because it's magic in a way. So hopefully this should result in this conclusion, that input validation and encoding and escaping and those kinds of things are all needed. So we looked at input validation, we saw the stuff that we could do there, but we also saw that we need the escaping and encoding and parameterization and stuff like that, because those are two different problems. And domain-driven security helps us with parts of this. It helps us with putting input validation in the right place. We have the domain objects that's flowing around. It even causes us to have better data quality because we have to start thinking about what these objects are doing. Like, is the quantity between 1 and 200, or could it be a minus in this case? So we have to think about that when we create the objects. And this can stop or at least limit lots of attacks because we suddenly start to reduce the sizes of things and the character sets of things and those kinds of things. And this causes us to get compile time errors if we do stupid things, which is excellent. Thank you.